And welcome back, everyone. This is the 10th annual virtual residency workshop. It's Wednesday, June 26th, 2024. And this is the panel on facilitating cloud computing. Our moderator is Wallace Chase. And Wallace, I'm going to turn it over to you to introduce the panelists. So go ahead.
All right, excellent. And Kiara to everyone joining here today, or hi for all my American friends. All right, this is a panel on facilitating cloud computing, and I've got a bunch of experts here along that will be talking to us about cloud computing and how we facilitate it and some different things around there. I'll have each one of the panelists introduce themselves now. Ken, do you want to start?
Sure, I'd be glad to. I'm Ken Taylor. I'm the cloud architect for the University of Illinois Urbana-Champaign. Um, what was the phrase? Why is this applicable? What do I bring to the table? I've been working in cloud since 2009, mostly in industry, and I'm 4 years into my higher ed position here at the university.
All right, excellent. Thank you, Ken. Liz.
Hi, my name is Liz Adams. I work at UNC Chapel Hill mainly as a researcher, and I've helping to support a certain application that does air quality modeling, and getting that available for people to use on the cloud.
Excellent. Thank you, Liz. Maureen.
Hi, I'm Maureen Donlin. I'm the Director of Research Computing at St. Louis University. I've been in this role since 2020 and have helped oversee the stand-up of several production workloads in the cloud, and as we continue to explore how the cloud can work for our researchers going forward.
All right, Jay.
Hi, all. I'm DJ Servino. I'm Executive Director of Research Computing at the University of Alabama here in Tuscaloosa. I pretty much am coming to this not so much as working directly with the researchers to get their workloads into the cloud, but mostly from the service delivery side. So hopefully can provide some insights into what we're thinking about as we roll out cloud services with other types of research computing across campus.
All right, thank you, Jay. And Tim.
Hi, my name is Tim Middlecoop. I work with the Internet 2 as a senior research engagement engineer. As background, I was the research computing director at the University of Missouri. Recently, I worked on the Internet 2 class program, which is cloud learning and skills sessions. So I got to learn everything about all the clouds and get to play with them. And I also work a lot with the research computing and data community, specifically within CARC.
All right, wonderful. And my name is Wallace Chase. So I work for the University of Otago in Dunedin, New Zealand. And I am the head of department for IT here. So that includes all sorts of different aspects, but it does include running the infrastructure behind all of our research cyber infrastructure, so HPC and all those types of things. All right, we're going to go ahead and get started here. Rattle off a couple of questions. I will say that anybody who has any questions or wants to put any input in, please just do that into the chat, and I'll monitor that as we go along and bring people in. If you are would like to talk or to speak back to the group about something, just indicate that in chat if you could as well. All right, we'll go ahead and get going. So the first question that I have for my panel is, when a researcher who wants to use cloud computing in their research first comes to you, typically how much experience with cloud and how much of an understanding do they come with, and kind of what's the range, and how does that affect what you do? Who from the panel would like to take a stab at that one first? All right, Ken, go ahead.
It ranges from the complete novice to an expert. And it's always interesting to see who steps up and says, I want to do X. And either they know or they have no clue. So you just take it as you come.
Yeah, I'll second that. And it's especially true, I think, with AI initiatives on campus. So when it comes to researchers who want just good old GPU, CPU stuff and they're ready to go, that's one thing. But if you have somebody who's like, I'd like some AI tokens, or I'm not sure how to do this project. I want to bring all my students into it because we've got this initiative, and suddenly you're starting to think about chargeback and what students will do and how they'll roll through that money or those tokens and all that good stuff. So, and they may not know any of that. They just know that this is something they want to do. So that's what I'm seeing, at least.
We've had mostly novice users come to us. They have a lot of domain knowledge and they're just trying to solve a research problem. And for whatever reason, our on-prem resources did not meet that need. And so moving them to the cloud has been, in some cases, the only solution. So.
So for my experience, we've been trying to train folks on how to run air quality models. And so to offer that training, we started using the cloud and providing small virtual machines with all the software installed, and folks can just use Canvas or whatever learning. We've been offering it through Canvas lately. How to like copy and paste this command and run it and see the result, copy paste the next command. And so we've offered that type of training, which is really a small use case, isn't real life for the type of applications they're going to need to use moving forward. And then, so some people come and they do not even know how to use the command line or don't know how to use Linux, or there could be a wide range, but by using kind of this how-to guide through the learning management systems and then giving them access to an IP address to log into, they can get through the training. And it's usually offered over like a 4-day period. So it's pretty intensive. And people try to do it as well as their job. So you don't always have their full attention, but it's a method to get people on the cloud.
Excellent. So one follow-up question I have for the group here is, do you find that there's better resources when it comes to cloud as far as documentation and that sort of stuff to get people going? Or is it worse than our traditional on-prem resources, or about the same? Are you having to recreate all this documentation, or is there stuff out there already to be used? Go ahead, Marie.
I would say that our use cases are so bespoke and so varied that there isn't any documentation to take them to where they need to go, or at least anything that's accessible. I haven't found the idea of a self-service cloud model to be viable in any sense, at least not yet. So that's where we're at.
I've really liked the documentation that I've been able to find in terms of creating high performance clusters on the cloud. But I have a lot of technical experience, and so I just needed to get a cluster up and running and to benchmark my specific application. I know how well it performs on our local compute clusters, and then can I reproduce that type of performance up on the cloud was my goal. And so I felt like documentation was good enough to get me up and running fairly quickly. But to instruct someone else on how to do that, I also created documentation for our specific application that uses some of the information that's available from the cloud vendors and then some that we've just needed to create as well.
All right, and that's one thing that we've certainly found is that there is a lot of documentation out there. It's not necessarily tailored towards what our researchers are doing. However, we do find there's a lot more out there because it's not necessarily a bespoke system that we've built up. And that for the facilitators and the engineers and the technicians supporting it, there's quite a bit for them to go off of already. And it's often a case of modifying existing documentation instead of having to create something completely from scratch, which is certainly handy. Had a couple of things come up into chat, and one is the question around, is NSF-access considered cloud computing? And Tim, you answered that quite succinctly. Absolutely, yes. And I would say that from you still all these years later everybody has a different definition of what is cloud. But for me, cloud is anything that's someone else's computer that you're accessing for a fee or in a commercial type of arrangement. So doesn't really matter if it's a hyperscaler or something smaller. It is cloud.
And Jetstream has significant resources, and if you're an expert, you can use the OpenStack interface, which is very similar to all the other clouds. So you can do infrastructure as a code and that kind of neat stuff. But they also have a really nice interface where you just click a button, you get a VM, and you're all set to go. So that's when I had researchers and they needed additional resources that I couldn't provide, I would always point them to Jetstream because it was a great way for them to get sort of the access to the machines and the privileges and things like that without having to deal with setting up those types of services within the environment that I was responsible for.
I've always thought that cloud should be a concept that's actually fairly, for anybody who's been involved in research computing over the years, should be fairly something that they can grasp fairly easily, because it's no different than how we run our clusters and that sort of thing today with things like Open on Demand and OpenStack and stuff like that. It's a very, very similar concept there. So another question we had was, how is your organization informing users about the presence of CI facilitators on campus to help with issues that they may have? Would like to take that one on?
I'll start, I think. We do a number of events across campus to be able to at least let researchers know. We also have a listserv that sends out information on availability of so even office hours we had established at one time where a researcher could actually come in person should they be on campus at that time during summer, for example, and stop in and get a couple hours with a facilitator just to go over their problems or whatever they're thinking about. We would help consult in those things.
Yeah, we also have the same thing. We've got office hours, we've got lunch and learns, we've got other presentations where we bring in vendors, to go over some demos or do a workshop.
And if those resources aren't available, you can always look at some of the national efforts. Access has a lot of things that they put out with Jetstream. CARC has a number of tracks that they invite folks in as well. And if you just browse the community, you can usually find lots of folks talking about cloud.
All right. So another question that we had there was, are cloud certifications necessary for effective research computing? And I would say for facilitation as well. Who needs to and who should have those certifications, and who are they valuable for?
Well, I don't think certifications are necessary. Most of the time, people are very focused on a particular use case that they want to achieve. And that use case is so narrow, you just need to learn that one thing. Like, I just want to set up a cluster. I just want to run my EC2 instance. I just want to get my machine learning running. And so in that sense, doing a certification isn't really helpful to the rest of it. Because they're very focused.
I would slightly add to that. I think certification can help learn. You may not need to take the test, but there's lots of course materials out there so you can learn different things and on your own pace and whatever you need. I would say you do need to understand how billing works. It can be complicated, but it's absolutely important how to set up billing and how to set up billing alerts, as also how to set up the visibility of your cloud and who can access it and the IAM, the access management parts of it. I would highly recommend that you have a professional set those kind of things up so things don't get away on you. And also just general cloud security things. Don't let that token get away, or you might find a $50,000 or $500,000 bill next week. So those kind of things, there's a decent amount of training out there for that. But in general, yeah, I don't think you need the letters beside your name in terms of the actual certification.
Yeah, I would certainly agree with that. And coming more from the service delivery aspect of this, much like Jay was talking about here, the security aspect can't be understated. And anyone who's using it, the more power you have, the more power you have to to make a mistake or do something that will have big repercussions in the cybersecurity standpoint. So we do need to be training and informing our users about that and making sure that they are aware of what they should and shouldn't do with the more levels of access and power that they get in a cloud computing stance. But also for the back end technicians and engineers and that who are running the system, I think as Tim said, getting the certification isn't necessarily important, but there are a lot of classes out there. A lot of them are free or close to free, to be honest, and offered by the big vendors. So there's a lot of opportunities out there to learn and to keep up with stuff. But the biggest thing that I've found, and this is something that we do sometimes struggle with in IT, just like anybody else, is just giving your engineers and your technicians space to play in the system and to use things and to set stuff up and to kind of learn organically. It's such a rapidly changing environment that if you got a certification last year, it's maybe not even all that worthwhile this year as far as what's actually happening out in the environment. Anybody else have anything on that particular topic?
I'll just make a quick note. A lot of the training is enterprise based, so you have to be careful that you're not learning the wrong things. The amount of research and scientific training out there is difficult. So just be careful what you get into, that you don't spend a lot of time setting up load balancers when all you want to do is doing compute.
And I'll echo Tim's comment on cost. When we create accounts for users, there's an automatic monthly budget limit set for them. We've had too many instances where we've seen runaway charges.
Yeah, I think that's important and that's an important thing for the IT teams or the folks that are actually running or providing the infrastructure to know about and to be able to competently set up before opening the floodgates there, because yeah, you could have a real flood if you're not careful.
And I think also on the back end, making sure that your researchers understand that you've got certain data protection agreements in place on the back end and guiding them to the correct cloud instantiation that is appropriate for the type of data that they'll be working with. So here at UA, we use Azure's GovCloud for anything that's NIST based or CUI, and just ensuring that researchers know what data they have, educating them about the type of data so that they're not misinterpreting that, oh, that's actually, that's not de-identified the way you think it is, sort of data, if they're working with MRI data or some other style data. So anything like that, I think is really worth educating people. It doesn't take a certification for them to know that, but it does take some educational effort on the front end.
Yeah, absolutely. Knowing that local environment, I think is our job as facilitators and the folks who are trying to help out the researchers. And a lot of that is around what are the restrictions on data, what are the policies, what are the different things, and really being able to help advise. One thing that we find is that oftentimes in these research labs, it's almost never the PI that's necessarily doing all this work. It's usually grad students. It's usually other folks that are in there helping out, that get assigned this big data set, and here go come up with this result, or go do this to it, and they don't necessarily know what to do and what the restrictions are. Mm-hmm. In New Zealand, we have a unique situation where we have what's called Maori data sovereignty. So the indigenous peoples of New Zealand, if their data is included in a data set, then you actually have to there's very special restrictions around the fact that data cannot leave New Zealand. So when it comes to accessing cloud and stuff like that, that becomes very tricky. Our closest cloud resources are in Sydney, which is another country. So that becomes very tricky as far as how we can deal with that data. You need to get permission for that data to leave the sovereign shores of New Zealand and go somewhere else. From the iwi that are responsible for it, and so there's a whole bunch of training and stuff that goes along with that, so that researchers know what they can and can't do with the data, and know that by putting it onto even just OneDrive or something like that, that is actually not resident in New Zealand anymore. So, all right. So, moving on here to another question. So, what have you found to be some of the top challenges of facilitating cloud computing? What's the most difficult things that we've come across in this respect?
Thinking people have money because they'll come and they want to know the exact cost for their exact grant. And of course, the grant has already been written and granted without any idea as to what they're trying to achieve. And so yeah, there's a lot of readjustment that must be made.
Along those lines, getting them to think about the mindset of cloud computing, that a lot of the resources can be ephemeral. You're only going to save money and it's only going to be cost effective if you can turn it down when you're not using it. I mean, if you're going to sit on a $30,000 CPU for 24/7, 365, it's going to cost you. But if you can spin it up and down as you need it, that's an important thing to realize. And it's hard to get researchers to think about those things. That requires you to, when you turn up a VM, to configure it with a script, not just sit there and have your pip install things that have been evolved over the last 10 years on your machine that you hug every day. You have to think about it as disposable items that you can automate. For me, the way I think about it is my cloud is my Git repo, and I just do a git clone and I run a command and it does what I need to do. That's the only state that I maintain is in that repo, and then potentially of having external data sets which I can pull down, do my data analysis, and then just throw everything away except for the results. So hopefully that's just a little graph that prints out, and the way you go, you don't have to download all your temporary data. And because if you do download things, you can get nailed with egress fees as well. There was a question in the chat around costs. And in general, it's very hard to estimate what the costs are going to be. You really just have to try it. If you ever look at a cloud bill, you'll realize that they charge for just about everything. You do one thing and there's like 20 or 30 bills will come from that. So you just really need to test it out and slowly scale it up. You can do gross estimates. How many hundreds of CPUs do you need? How many hundreds of terabytes you need? That will get you how many zeros that you may need in your estimate, or number of, is it thousands, millions, or billions of dollars?
Yeah, introducing people to serverless technology is often very interesting, because they go, why isn't it running 24/7? Because you don't need it running 24/7. And so getting them to adopt a serverless database is really phenomenal, because they go, well, this is really inexpensive because I only need to query it every so often.
Yeah, and we find that there's similar challenges here to what we face on the enterprise side of things, which has maybe been working in cloud for a bit longer. In that the billing, it can be very difficult to decipher and very difficult to figure out in advance. Oftentimes, the best method is to start slow and just kind of ramp up and let bills come in and kind of watch what you're doing and do that. Unless you've got the funds to have some real experts in your corner to decipher the billing. Often that's the best way to do it there. Anyone else on billing and estimation of billing?
I just echo what others have said. It's incredibly difficult to predict it, particularly if you're moving into an area that, like we did this huge ETL, extraction transform load project for a group in finance, who were working with like a half a petabyte of data, which we couldn't support. And honestly, it took a couple of years to build that out to the point where it would do both what they wanted, but didn't absolutely break the bank. And just finding the people who understand all the nuance, where everything we do so far is in AWS, finding someone who understands the nuances of how the different services work and the constantly changing services in AWS is probably one of the biggest challenges we face.
There's an entire degree or field called FinOps, financial operations, and how you spin things up and how you do things can make orders of magnitude difference in the cost. For instance, how you use a service like Glacier, it can be cost effective, but if you do it wrong, it's not going to be cost effective at all. It'll cost you even more. Simple things like, do you store everything in a tar file and you stick it in there, or do you put individual files? Well, if you do individual files, then the metadata transfers are going to kill you. And you have to know these things for each and every single service, and they change. And so you just have to be aware of it and have partners that can help you with that, whether it be the folks at the cloud providers or somebody at the university who is trained with this and can help you with those types of things. And also maybe give you access to things like reserved instances at the university where they actually buy at a lower cost capacity and then can hand it out based on need.
Yeah, I find that just the mindset change that IT departments have been going through for many years now, from CapEx based models to OpEx based models. This is like the ultimate iteration of that. And can be very difficult for people to wrap their mind around. It can be very difficult for researchers who are getting often fixed chunks of funding in order to do their research to also wrap their mind around. So if you're in IT, I would say think back, 10, 15 years ago when you started your journey into cloud, and that's what most of these people, that's where their mindset is at right now, is that transition from a capital-based model into an operational-based cost model, which is difficult. All right. So moving on to another question here. So, and this one is always a fun one. So what's the worst mistake you've made or seen made? Don't have to necessarily implicate yourself here in facilitating a researcher's use of cloud computing. Maybe they made it. Maybe it wasn't even a facilitator.
I'm willing.
I'm sorry. Go ahead, Maureen.
I'm willing to drop it. So when we first started, because we didn't have a lot of, we still don't have a lot of GPUs on our campus, we have a researcher who wanted to do this molecular dynamics simulation with a large protein. But, oh, perfect cloud use. Spin it up. Wouldn't have to do it again. Yeah, we made too many assumptions about, one, that the postdoc doing it knew what she was doing. We didn't have guardrails. There was no checkpointing in the software. And multiple weeks and a $10,000 bill later with no output was the outcome of that. AWS was kind enough to knock most of that off, but that wasn't a great start for us. So
yeah, we've seen six-figure overruns, mostly due to grad students. So, again, it's you don't have the guardrails. They're not spinning things down. They just leave it running over a weekend, over a month. And yeah, then you're stuck with it. So yeah, and you're absolutely right. The vendors have worked with us to get refunds on certain issues that, there was an idle machine for a while. And we've done that for a variety of customers across campus. So yeah, you got to watch it and you got to help people set up those guardrails.
Mm-hmm.
And the thing is you need to look at the tools within the environments more than the third-party ones, because some of those have a lot of delays. I have one environment that'll give me a 4 or 5 day delay. So if I forget to turn something off, I won't know for 4 days. And that's, to me, not acceptable. So I always have scripts, or I know what screens to go to see what's running, and I can see the actual state. And whenever possible, I try to get up to date access to the billing. And if I don't have access to the billing, I yell as loudly as possible and make sure that all the emails have been CC'd saying, I don't have access to the billing, so how am I supposed to control this? So if something does happen, then I'll have a little bit of that email. The other thing to note about billing credits, it's usually a credit. They don't give you cash back. So if you got a six-figure mistake, you're going to be spending 6 figures sometime, just not right then. So, for researchers, I think it's important to communicate to them that they need to go through the university for those protections, and also the power of the spend, but also some of the other things that can go on, with personal liability with putting it on the credit card. I haven't been a director for a while, so I'm hoping researchers are still not putting it on their personal credit cards. But I imagine that does happen.
Absolutely, 100%.
Yeah, it's especially there as two things have happened. One is we do get researchers who choose to go off on their own and negotiate their own
Mhm.
environment with one of the big three. And that's where we've seen some folks run into trouble because they either forget the guardrails or they're not really going through us as a proxy to help them, just put eyes on what they're doing. The other thing is obviously is that as we have all these kind of AI initiatives on campus, we're seeing a lot more students, undergraduates getting rolled into using
Mhm.
HPC and cloud type services. And so I just think it's going to be natural that more mistakes will be made regardless of what we've got going on in terms of guardrails. That's like the least thing we can do, but there's a lot more that we'll have to be paying attention to as we go forward here.
Yeah, we've seen a lot of perhaps good intentioned free credits, and I'm just going to go off and do my thing. But oh, I had to put in my credit card too to get this going. But oh man, as a student or something, will come back and say, I now have several $1,000s on my personal credit card for this help, and we're like, well, that's that's tough. I would also just say that there's definitely a very large shift in the market dynamics right now around cloud and cloud providers. I would say software and hardware providers just in general, where higher education is rapidly not becoming the loss leader that it once was for these companies. And as you see cloud growth slowing, which it's slowed dramatically, public cloud growth, they're looking to now get revenue out of all the opportunities that they do have, and that includes us to a large degree, unfortunately. So I think over the next couple of years, in my personal opinion, we're going to see a lot of pullback from a lot of these large vendors and being quite so generous, maybe, to the community. And that as the growth of public cloud perhaps starts to level a little bit, that there's not as much need to be promoting that from their angle. That's going to shift much more to getting in revenue, and that'll impact us. I know that's impacting us on the enterprise side of just about everything, where folks like Microsoft have been very upfront about it and will, in an executive briefing, tell it to your face. Higher education is no longer a loss leader. We need to make money off of what we're doing. And I think you see that with a lot of the things that they're doing around AI and that, where there's significant costs associated with it.
The one thing we try to do with a researcher who's using their own credit card is entice them with, enterprise level savings. So
Yeah.
that right there is worth joining because you don't get that 11% discount or whatever it is. So yeah, I think it's imperative that we pull in as many researchers into the fold so they can get all the benefits of that.
And just as a reminder, this is for commercial cloud. If you happen to be on Jetstream, then it's like credit based through Access. And so, yeah, you're still wasting resources, but you're not going to get a bill, and they can be friendly in terms of things running away on you and getting credit back for whatever credits that you have. So if you can get away with using an Access or using Jetstream or some other services, then that's definitely the way to go.
How many of your institutions have perhaps stood up fairly robust private cloud infrastructures that mirror what's available in the public cloud, but make that available for your researchers? And how effective is that at stemming some of these problems? Not all. Obviously, you lose some of the benefits of public cloud by doing that, but
Yeah, we're lucky enough to have NCSA, National Center for Supercomputing Applications, on campus. They've had a really large cluster for many, many years. They've also built their own HIPAA compliant environment, a smaller cluster, but nonetheless available. And they're part of Access, so you can get time on their machines. And the university is also realizing the cost of these things are becoming more expensive. The university has opened up a fund for researchers to make use of these on-site materials.
Absolutely. I saw a comment that just made me chuckle in the chat here that a lot of our onboarding lately is through faculty who tried to get their personal Gen AI service subscription reimbursed. So that's a good example of us being ready on the IT side to catch the folks as they come off the bleeding edge, perhaps bleeding, as I like to say it. So, all right. So going on for from the worst mistake potentially, what have you found to be the top challenges in facilitating cloud computing? What are the most difficult things that come up?
Me. Learning all the clouds. The clouds are a huge mind space. And if you think you can learn all three and other things as well, like Kubernetes and each one of the services, you're just deluding yourself. Yes, you can be a generalist and learn about the general ways that the different cloud providers change and are different. Just keeping up with the names is difficult as well. They all call things very differently. So if you're going to facilitate, I think you need to stick to one provider so you can get some good service around costs and how to set up access and policy controls and those types of things, and what services are good for what things. I mean, AWS is the poster child of having 12 services for every one thing they're doing. There was a joke floating around, I forget the actual number, about how many different batch systems that AWS has, and it was a really big number. So that's the biggest challenge I think as facilitators we have is balancing how do we learn everything with actually being effective. And I would my suggestion for that is pick a cloud and maybe a cloud and a half and go from there.
That is a potential large challenge for smaller institutions to tackle going forward, and that's where knowing about resources such as what Internet 2 and Jetstream and all these other things provide, it can be very useful. Jay, sorry, didn't mean to cut you off.
Oh, no, absolutely. Yeah, and it really is reflective of where you're going to put your training dollars for your staff, so that they can help facilitate, and especially if you've got an on-prem environment as well, and you are trying to split between that and all the cloud support, it just becomes sort of untenable. So really, I don't know, maybe it is where there's just got to be as much documentation as possible, or at least pointing to the places we've talked about before where you can get that as best as possible for the researchers to kind of do it on their own.
Yeah, I think that's that constant tension that certainly that I know central IT departments see is between providing a robust but potentially narrow service offering and trying to support all the bespokeness that happens within research can be a very tough thing when you're also trying to deal with what is inevitably a constantly shrinking budget and rising costs.
I would echo what Tim said about focusing on one cloud, particularly if you're a small team. We're only in AWS for that reason, although we're putting a toe into the Google cloud provider. I'm afraid to find out just how many personal accounts are actually out there on Google when we do that.
Google does tend to go around throwing credits out like candy, so
yeah. But it's just we're kind of in the opposite situation of most, and it's the research is driving all of the cloud. Our central IT is doing almost nothing in the cloud, which is a little on the odd side.
I don't think you'll find that to be all that unusual, actually.
But
spoken from somebody in central IT,
yeah.
Who's trying to do things and guide in cloud, but it is definitely research led for us. And as I said, we are sometimes the ambulance at the bottom of the cliff waiting to catch the bleeding edgers as they fall off. Liz, I'm going to put you on the spot slightly here because you've got a little different perspective than the rest of us, perhaps. What do you think are some of the things that the rest of us who are in support of people like you should be concentrating around doing? What are your main what have been your main challenges that you wish you'd had more help with?
Well, so I mean, I think for one thing, a lot of our AWS is on a credit card. So I hear the caution like, oh, you shouldn't be doing that on a credit card. You should be doing it through the UNC system. But for us, being able to independently run our trainings was important. We needed to be able to spin up our EC2 instances or spin up our clusters and when we needed them. And so learning how to do that and quickly and breaking things and we did not kill our budget because it's mainly just me or maybe me and someone else doing it. But we are pretty strict on how much we have available for a budget, and we have to figure out how much it'll cost to run 20 EC2 instances for the trainees who are taking the training and not break our not break our bank. But so I don't know how the UNC research IT department could help with that necessarily. They did help us. We started like exploring how to do the parallel cluster work with their help. And so, and also, especially when we went to Azure. So we also learned how to use Azure Cycle Cloud. So talking about this, learning two different cloud systems, two different operating systems, two different everythings was very complex. And having eyes on what we were trying and saying, oh, like we were hitting a problem on Cycle Cloud where the file system wasn't fast enough to support our application, but Lustre wasn't out yet. And so we had to get in with the Azure Cycle Cloud folks, and the IT department helped us do that to get an early access to that Lustre file system so that we could continue the work. So, I guess being aware of what the researchers are doing and when to step in and help and when they maybe don't need help is the best thing. But we don't have those monthly meetings anymore. And so I think the work is kind of slowed down. And the other question is, who will the air quality modeling community start to explore these resources? We provided the tutorials. Will people start to try them? And is there a role, I guess, in universities to say, hey, these resources are out there for folks. If you would like to learn how to use a parallel cluster or a cycle cloud for a small test case, and then see if that sort of infrastructure helps for your application, that would be one way to go. But I don't know. I think we put a lot of work into getting our application running in the cloud in parallel and using the resources efficiently. We have all these plots showing how many cores you use, what the cost will be, depending on your domain size, et cetera, et cetera, et cetera. I think it's just a matter of then what are the next steps? If we provide all the data that people are asking for, the costs, the how-tos, what will people need to take the leap to use the resources? I don't know what that answer is.
Yeah, I think that's actually a fairly common thing, even just outside of using cloud, and that is the development of tools being used for research, IT-enabled research things has always been a very tricky thing, because there'll often be research projects that'll come up with this great tool set or something like that, but research projects are often time limited. They don't run forever. Not every research project like this that develops a tool set or a methodology for a particular discipline is able to turn into the next Globus and become an actual business and move forward. So that's often a big challenge for these things. And I think that one of the ways we can get around that are communities like this, where we're able to talk about these things. And hey, Liz has done all this work on this, and she there's a ton of information coming out of her lab and her research work. We got somebody at our institution, we can say, hey, let's tap into that. Let's look at that and see if that will help solve some of the problems. Somebody else has probably done the work already. It's just, can we find it? All right. So this is a question that I put in or earlier, and I think it's prudent to ask it now. So, in your institution, what is the split between centrally provisioned cloud services and unmanaged or the everything else cloud services, and how does that impact the way you support it, whether it's a centrally managed thing or a researcher went off and did a thing?
It's pretty much the same, whether we're hosting the course catalog for everybody on campus to schedule next semester, to an individual researcher who's just running a database on an EC2 instance. It's the same. We take all who have questions, who have needs, who need something explained, who need something analyzed.
Anyone else on that one?
I think our bleeding edge researchers who decide to go off, they're pretty much on their own, which it's just unfortunate because we just don't have that many headcount to go around and support them. I mean, I think where we bring value to them is in the once we get enough I don't know, impetus behind a particular platform, we will bring it in with an enterprise level agreement with that company, like we're doing right now or just finished doing with Google. But the thing to keep in mind there that researchers often don't get is that it takes, once there is a drive for one of those platforms that you don't previously support, it's going to take time to get that up and running and going through and finished with legal and all that good stuff. So, and sometimes the researchers aren't willing to wait for that. Sometimes why they go off on their own, but they've got their deadlines, which we appreciate, but then having to bring them back, having to do the thing where you kind of bring them back into the fold is also, it's extra work, but it is completely worth doing if they get that guidance and they've got that umbrella of central IT services helping to support that back end, so they don't have to burn cycles doing that stuff and can dedicate it to the research.
They're on their own if they've gone off and started their own. We don't have the headcount to deal with it, and I may or may not be aware of it even happening. So.
Yeah, and I would say that we have a little bit of the same strategy where they are on their own a bit if they've gone off. However, from putting my enterprise IT hat on for another second here, is that we still are responsible for cybersecurity across the entire organization. I have a CISO who's responsible for every bit of data, whether you've gone off on your own or whether it's within my data center in the central payroll database. So that's where things often will become quite tricky. And especially when you start to get into situations where you get audited by the government or something like that, which does happen here, probably not as much in the US, but does happen here. And then you need to be dealing with that. So I think we're really leaning on education very heavily there, and on informing all of the end users, the researchers, the faculty and the staff around what their responsibilities are if they're creating, holding data. What are your responsibilities and what are the institution's responsibilities at the end of the day? And that's a tricky conversation. I'll often say to my CISO or anybody else who's in a CISO position within a university is that I don't want your job. That's the hardest job in the university. You never win. All right. Let me look here through. We've got a bunch of questions that have come in here. One is a little bit more of a technical question around how is internet connectivity handled between campus resources and cloud accounts? Do you have a hub and spoke model or do you have a different model in place?
I'll reiterate some of the comments I made. There are services at Internet 2 to set up Direct Connect, so you can make connections between the university and the various clouds. And there's other services that are around routing as well. I'm not overly familiar with them, but there's lots of fun magic that you can do in terms of moving data around. A lot of times, though, those require long, sustained amounts of data for it to make sense because there is a decent amount of effort to set those up and tear those down. But from a university perspective, if they're doing a lot of work with one of the providers, they can set up a direct connection there, and it can make sense in terms of the costs or the reliability or having a redundant routes and things like that. Or it also might be a compliance thing where you don't want to route secure information over the public internet. So there's some tools that are available there. But in general, if you're doing things right, you should not have a lot of traffic between the campus and the clouds, because all you're doing is SSHing in or using a web interface, and then the data is coming down from the source. But if you do have some large on-campus data repositories that you're syncing with the cloud, then you may want to look at those numbers. But those would be quite large numbers before they become economically viable to go down that route.
Yeah, we've at Alabama been using Azure for quite a few years, not only for research, but also for our DR as a geolocation elsewhere for our disaster recovery. We have yet to need ExpressRoute for that, which is the bigger bandwidth connection to it. So, and they're kind of waiting for that critical mass in order to get that. But so far, so good. Let's put it that way.
Yeah, for us, it's been so we've got a little bit of an advantage here in that New Zealand has an NREN, much as Internet 2, that provides direct connect and express route connections at no cost, basically, to all of its participants. So we've been able to have that set up very early on in our evolution here. The problem always is those researchers that are off on doing their own thing, and then they grow quite dramatically all of a sudden. We have some very large scale, and as I said, this comes back into concerns around data sovereignty and where the data sits within the country construct, which isn't as big of a problem in the U.S. obviously as it is for us. So we have a very large scale storage solution that is on-prem on our campuses as a result of that, because there haven't been traditionally easily accessible cloud resources for us for storage, or there are problems using it, such as the nationality thing. So we do have some of those issues. We've really tried to push very hard a pretty large network of Globus nodes put all over the place, and use that to actually be able to build into researchers' workflows to be able to transfer data back and forth. But again, that's not necessarily that doesn't necessarily tick all the boxes, but it does help in some of those cases to have that sort of thing set up.
And a lot of the times, if there are issues, they can often be easily resolved. So if a researcher is showing slow download speeds or upload speeds or transfer speeds, look at the campus infrastructure first, and then maybe there might be something strange between the campus, the regional, and the national. But for the most part, the pipes to the cloud providers are quite large. And so if you're on the National Research and Education Network, then you should have no problems getting data in and out. And so just check along the paths. And that's the great thing about Research and Education Network, how these folks talk to each other all the time. And they know the personal relationships, and they can sit down and say, hey, what's going on here? Why is this traffic going across the country and back? And those types of things. And you have to take a look at how the researchers doing it as well. If you have your compute on the East Coast and your storage on the West Coast, it might be slow and it might be expensive. So you have to take a look about where is the data located, where's the compute located, what kind of things are you doing? There are certain things that don't work well over long distances. So it's not just a simple fact of let's put a really big pipe between the campus and the cloud providers. It's about getting the network working pretty fast. Anything above a couple gigs, then you start to need to tune along the ways. Anything up to a gigabit, you can pretty much do fairly easily. So.
Yeah, it's not as big of a problem as it used to be, but here in New Zealand, US East 1 for AWS has been the bane of our existence, because everything seems to start there, and that's about as far away from us as you can get in the cloud space. So yeah, especially a lot of genomics companies seem to have located themselves there and only there, which causes us problems sometimes. But anyways, so one question that I have back for the group is that if you are a smaller institution and you've got a limited amount of facilitation staff, or even if you're a large institution that just doesn't have a lot of facilitation staff, where should you start? Where should you focus your attention on in order to become more cloud aware or cloud savvy for your researchers? How do you maximize your investment there? Oh, you're still muted.
Um, I can tell you what we did at SLU because we have a facilitation team of two, and only one of us is, and it's not me who's really a cloud native person. Is we've gone with contractors. It, we work a lot with the solutions architects from AWS, but they don't in the end do it for you. And so we've ended up using contractors. We found one now that we're really pleased with and are working with them, but that's been our route.
I would say invest in training and invest in hands-on experience. There's nothing that gives you better understanding how it works by actually doing it yourself. And I would also say that experience outside the canned training that they have. Those canned trainings are typically, copy paste, copy paste, copy paste. Well, you can't do that for your researcher in a total different context. So getting some hand-on experience and getting some quality training. The class program at Internet 2 has some research-based training as well. But just in general, playing with it and working with a researcher one-on-one and don't go beyond your capability to support whatever group. So find some researchers that are good to work with and that are wanting to move the cloud and work with them individually and help them along. And in the beginning, let them know that this is a pilot and we're learning together. And just so when they talk to their friends and their friends want the same level of support, that you might not be able to give it to them, but just learn through that particular process. So if they have a question, go in and explore all the options and also talk to your peers, right? There's a lot of communities out there that are involved with cloud and research as well.
Absolutely.
And don't be afraid to try third-party tools that'll help you manage things better. So investing in a tool, obviously you need the training there, but there's lots of stuff out there where people are help manage your costs, help manage the security, help manage the accounts. All of that is quite useful, and there's plenty of options.
And there's a number out there that are also research focused as well. So you can take a look at them, and they take a research first approach to how the system's set up and the provisioning as well. So it isolates the complexity of the cloud for folks as well.
The higher ed cloud forum has been invaluable in terms of finding people to talk to and learning from them.
It's a very good source of what tools are handy tools to get as well. Because as I said, if you're already on a small team, you maybe don't have the resources to go and do a massive, RFI type of thing for all the different options that are out there. It may be it's a good way to get some information on that. I would second that a lot of the tools that are out there are very handy, and there's some very good ones out there. It's always personally hurt me a little bit to have to buy something to figure out how much money to pay somebody else, but there is an ROI there for sure on some of those tools when it comes to the billing and how you're setting up your environments, especially as your environments start to go broader than just your core engineering team, perhaps in the enterprise side, and go out to the general community more. So, what level of service visibility do you grant your researchers? What kind of dashboarding or service? How do your researchers know how much that they're doing?
In terms of cost or in terms of just doing the work?
Yeah, I think in terms of cost, let's do it there. That seems to be what most people are very concentrated on here.
Yeah, we've really tried to introduce people and show them how to use, the billing environment in the cloud so that they, one, know where it is, because that's half the battle, and two, that they should keep their eye on it.
We've
Well,
adopted Kion for management, and we provide them access to the billing, or are in the process of providing access to the billing panel within that in the reports.
we just provide chargeback, for our central platform, so they get to see what they're using, and we've got a number of pre-gen reports that they get so that they can track their trends and things like that.
So my
All
only
right, now
sorry, my
go
only
ahead.
suggestion is to make sure that the researchers have available access to immediate data, that there's not a sizable time lag between when something actually happens and when they see those bills. It doesn't take long to accidentally spin up a whole bunch of things. So some of the clouds are structurally, it's very difficult to do those types of things, but I really think it's worth the effort to make sure that there's a high quality flow of data between whatever environment that they're viewing it as in, and allows them to react quickly to things, and with low level granularity to see what some of the impacts of their decisions are. So not just a big bill at the end, but interzone and interregion transfers and things like that.
Absolutely. So no discussion in 2024 would be complete without a question around AI. So I'm going to put that in just so that we're complete and we've done our duty as technologists here and asked the AI question. So how has AI impacted the cloud landscape when it comes to researchers, research facilitation, any of that? What would have been some of the impacts that you have seen that AI has brought to the scene? Is anybody doing AI
Just
in the
more
cloud?
to
Everybody
deal
wants it.
with. It's just more to deal with, that's all.
Yeah,
More
yeah.
links, more connectors, more tokens, more everything.
How many of our institutions out here, and this is for the audience as well, are primarily dealing with access to GPUs and AI instances in the public cloud instead of doing anything necessarily on-prem?
I'd say it's mixed. Some people are using the cloud and some people are using the local stuff. So I don't think it really matters. I think the bigger issue is access to the GPUs, and then how do we pay for the GPUs?
Yep.
I'll add that I think we've had more requests lately for access to more cutting edge chipsets and things like that from our vendors to start testing models and workflows and everything sooner than we used to see. So we're getting a lot more requests for those types of things.
Right. I'll go through each one of you now, and I'm going to ask you a question as far as what are the top two things that you would want somebody coming into the field of research facilitation in the cloud context to know about, to be aware of, to do, to act on, that sort of thing. What are the top two things that you might tell somebody coming into this field? And I'll take a volunteer for who wants to go first. Liz.
My top two things are, at least for our field, data is a big part. So being able to share data through the open data warehouse that AWS offers, so we can upload, I don't even know what's beyond terabytes, but it's beyond to their warehouse right now and share it. And it's because it's through their program, there aren't any egress costs to the folks that are downloading it. And so the ability to reproduce and do new science using data that's provided through the data warehouse is I mean, you could still download the data to an on-premises system and then run the air quality model from there, but that ability to share the data quickly without sending, I mean, the old method of sending things through the mail, hard drives through the mail, whatever method was used, it's a nice thing. So that and the tutorials that we're offering, I think, are being able to follow a workflow and get an estimate for what your cost might be by running a 2-day benchmark or whatever your benchmark is for your research, getting that exact cost and then being able to extrapolate that to see if you would like to use the cloud, perhaps for something that you as time critical. And if you're stuck in a queue on an on-premises system, you can't get the work done, you may consider using the cloud. There are use cases where you might want to use it, and the key is to understand your costs. And the way to do that is to, try out these HPC clusters in the cloud for your application.
All right, who'd like to go next?
I'll go next. Beyond setting billing alerts, I would say when you're working with researchers, give them well-developed templates. The templates can help an awful lot, and make sure you bake in best practices to those templates. Don't just copy them from a website and hand them off. Make sure you understand how they work and make sure that they're secured. And don't give them examples that are from, don't do this in production type things, right? Go through the effort of making sure that these are ready for production. I know research is not production, but that statement comes around, like, oh, let's just turn off security so that we can get this example working. Never ever show people how to do that, because they'll run with it and use it regardless. Always show them the proper way of doing it. And it may take you a while to go through the process to think of what is the nice balance between being secure and being easy of use. And that'll give your researchers some great tools that you can hand off to them, and then they can own these templates and show them maybe where some of the dragons are and to be careful in some areas. But yeah, just give well-developed templates and make sure that the researchers know how to use them properly.
I'll echo all of that. If you're not watching your systems, then you're not paying attention to how much it's costing. So we have to keep reiterating that to everyone. The comment in the chat, idle resource notification. We have done that for some people. We've shown them how to do that. But usually the idle resource notification is at the end of the month when they go, why is it this expensive? So then you have to get the bill out and go through it and then go to their accountant and see what they're doing.
And
Jay.
I'll say, especially for projects that are well-funded or large projects, make sure you've got a good service level agreement between your facilitators and the project, because there is a lot of work that is required, that may come across as being systems administratory, and so you run some risks of really having it become blurry of who's supposed to do what. So I would recommend trying to build just a standard systems administration or standard service level agreement and refining it to the different projects that you're working on. And it also helps with things like having an understanding of how identity management is going to happen for the project, which can be challenging, both from it might be completely manual in some places and not manual in others, or it could be completely federated if you've got a lot of external collaborators. And so how that's all going to work. And so there's an understanding between the parties about how things will work and what we need to consider to be the work that they should be doing and facilitation we should be doing.
Maureen.
That just because we're going to do it in the cloud doesn't mean it will get done faster or easier or cheaper than what we might do on-prem. And what we face is a lot of users haven't had to pay for compute on-prem, and now they do. And when they move to the cloud, and that's that sort of transition has been a challenge.
We've had several research groups that have rubber banded on us or boomeranged, gone out to the public cloud, blew all their money, came back. So yeah, absolutely. So we have a question from our audience here from Dina. Dina, you want to unmute and ask us your question?
Hi, I would have typed, but my eyes are done. My question is, how do you deal with the fact that all of the training that's out there basically starts with step one, get everything full admin permission and blow holes in all of the security, right? The training that you copy and paste is nothing you would want to use in enterprise, but that's what everybody's trained on. How do you find training that is secure enough to actually produce something useful for folks?
That's a great question. And how do you deal with that when you've got AWS or Microsoft dealing directly with the researcher and telling him all you need is all this access and you can do all your wonderful things you want to do? I'll let my panel answer that one. Any ideas? Has anybody actually figured that out yet, other than to cry in a corner like I do?
It's one of the goals of the class program at Internet 2. So you may want to check that out, internet2.edu/class. And it's researcher based.
We've actually sat down with a few researchers when something wouldn't work and give them the appropriate permissions. Showing them, how security policies work, showing them how to, create a programmatic user. And that programmatic user is actually running their code and has limited administration privileges. And by doing that, they feel a lot safer saying, okay, my program isn't going to run away and, do other things. It's only going to have the ability to read and write this particular, storage location and this particular EC2 instance.
I think for the facilitator who's learning these things, what you know about identity when it comes to traditional systems is totally flipped upside down when it's in the cloud. So you have to realize it is a different model. It is very different, and make sure that you understand it. It took me 6 months before I realized that it was even different. And then I had a little bell go off in my head. So, oh, wow, this is not what I thought was happening. So just know that how identity and access is done very differently in the cloud. And so understand that.
All right, excellent. Well, I think we're just about out of time here, but I will say that I think the closing comment here should be from Nicholas, who says we should just all win Powerball because money solves all of these problems, correct? All right, I'll turn it back over to you, Henry. I want to thank my wonderful panelists for their insight and wisdom here, and for the audience for asking some great questions. Over to you, Henry.
All right, thank you all, and let's have a round of virtual applause for our panel. And I'm gonna go ahead and shut off the recording.